We have a question right here. We are asked to analyze these circuits in S domain and find the transfer function. There are three methods we can use to do this. We can use KCL, we can use voltage divider rule, or KVL. Let me draw this out so that we can see it. So this is our first method. Using your KVL to solve it, this will be positive, 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 negative, negative, negative. So analyzing this, you have your V in of S minus VR S, because we're doing it in the S domain, minus VC of S is equals to 0. So making V in subject to formula, V in of S will be equals to VR S plus VC of S. And we know that in our S domain, your VR of S will be equals to, from Ohm's law, your R multiplied by current, while your VC of S in your S domain will be equals to over CS multiplied by current. So substituting this inside your formula, you have V in equals to R dot I plus 1 over C of S. But you know that your from over here, your V out is the same thing as your VC. So your V out is equals to your VC equals to 1 over CS dot IS. So making your IS and subject of formula, you have this. So you now have your IS to be equals to V out times CS. So substituting this inside your formula, you have V in, so R multiplied by your V out of S dot CS close bracket plus 1 over CS multiplied by your V out of S dot CS. So from here, your CS cancel your CS. So you now have V in of S to be equals to your RCS dot V out of S plus V out of S. So factoring out your V out, you have your V in of S to be equals to V out of S, open brackets, RCS plus 1. So, and your transfer function, formula for your transfer function, G of S will be equals to your V out of S over V in. That will be equals to 1 over RCS plus 1. So this right here is your transfer function using your first method, KVL. using KVL. So now let's use our second method, and that's voltage divider rule. We know formula for our voltage divider rule is V out. Let me paste the circuits that we can see it. That for voltage divider, your V out S will be equals to your V in of S multiplied by the impedance, your output impedance, over your total impedance. Z total will be equals to the impedance of your resistor, ZR, plus the impedance of your capacitor. So that will give us your R plus 1 all over CS. That will now be equals to RCS plus 1 after adding it up. I hope you understand it, but our Z out will be equals to ZC because it's right here, it's outside here. So that will now be equals to 1 over CS. Substituting it inside your formula, you have your V out to be over V in. That will be multiplied by where's the Z out as 1 over CS. Your RCS plus 1 all over CS. So from using our mathematical knowledge, this we cancel out this. Your V out therefore will be equals to, because your V in of S dot 1 over RCS plus 1. And we know our transfer function G of S is equals to your V out over V in. That will now be equals to 1 over RCS plus 1. Consider this formula is kind of straightforward once you know how to use a voltage divider. So the third method 3, that's using KCL. Using this as our node that we're analyzing. From here, we know that your IR will be equals to your IC. But what is your IR? Your IR is equals to be your V in minus V out all over your R. That's the current flowing through your resistor. By your IC, current flowing through your capacitor, will be equals to your V out over 1 over your CS. So this will not give you V out S multiplied by your CS. Substituting this inside this one. So you have IR. What is your IR? V in minus V out. Equals to your V out S dot CS. So cross multiplying. When you cross multiply, you have your V in of S minus V out of S to be equals to your RCS dot V out. Making V in subject of formula, V in of S will be equals to your RCS V out of S plus V out. So factor out your V out. You have your V out of S from brackets your RCS plus 1. Then we know for our impedance, for our transfer function is V out, formula for our transfer function is V out over V in. Dividing it, we now have 1 over RCS plus 1. You can see that using different method, got the same answer for our transfer function. So you can use any method of your choice when finding the transfer function of an RLC circuit. So we have an RL circuit. So let me draw it out so that we can see it clearly. Using voltage divider rule. Your voltage divider V out is equals to V in plus your Z out over Z total. So your Z out means your Z total. Sorry. Z total be equals to your resistor plus your inductor in S domain, and your Z out be equals to your LS. So substituting it inside this formula, we have V out is equals to V in of S multiplied by, what's your V out? That's LS over R plus LS. And we know our transfer function G of S will be equals to V out over V in. That will now give us LS over R plus LS. So consider voltage divider. Using voltage divider is very easy. Now we have an RLC circuit. We are going to be using voltage divider. Let me draw the circuit so we can see it clearly. Using voltage divider, your V out equals to V in multiplied by your Z out all over Z total. Your Z total will be equals to the inductance of your resistor, your inductor, and your capacitor. ZR plus ZL plus ZC. And that will be equal to your R plus LS plus 1 all over 6S. Adding everything together, adding the fraction, we have RCS plus LCS squared plus 1 over 6S. Now Z out be your um, the impedance of your capacitor. Okay, that's ZC. That's 1 over CS. So substituting that into our formula, we have V out S equals to V in multiplied by 1 over CS over RC S plus L CS squared plus 1 over CS. So these two can cancel. Your transfer function will now be equals to your V out over V in will give us LCS squared plus RCS plus 1. You can also, this is a transfer function. You can also try out other methods using KCL, KVL, to check if you get the final answer, but your means arrive at the final answer.